Hello everyone, I am your friend Shadab Imam and currently we are dealing with the topic of game theory. So till now we have learned that in any game theory problem we will first try to find the saddle point, and if the saddle point occurs our problem terminates, and if there is no saddle point in the game then we will try to reduce the matrix using the dominance rule and then solve as a mixed strategy. Now, will it be possible to solve a pure strategy, that is a game with the saddle point, by dominance rule? So this is what we are going to see in this particular problem. So please watch this video till the end, and if you are new to the channel, please subscribe the channel and don't forget to hit the bell icon. So let us move on to the problem. Here the problem says that reduce the following game by dominance property and solve it. So we need to find the solution by dominance property of this particular matrix. So first of all, let us see if there is a saddle point or not in this. So let us quickly calculate row min here. Row min. So the minimum value in each row is coming as, this is 5, this is 0. Now among these minimum values we will select the maximum value. So 5 is the maximum value and this will be our maxi-min value. Now let us find out the column max value. Column max. In this we will select maximum value from each column. So this will be 6, 5, 7, 7, 6, and among these value we will select the minimum value, which is 5, and this value is known as minimax value. Minimax value. And from here we can see that the maximum value is equal to the minimax value. This suggests that this matrix or this game has a saddle point which is located at the intersection of this row and this column. So at this particular location our saddle point exists, and with this we can also say that the value of game for both the players is given by the element at the saddle point, or we can say that which is the value of maximin and minimax. So the value of game is 5. So now let us see that if this problem can be solved by dominance rule or not. So let us now try to find the solution of this problem using the dominance rule. So in dominance rule we will compare rows and columns to find the dominance. So let us compare the rows first. Let us compare row 1 and row 2. So this is greater than this, this is greater than this is lesser than this. So that means row 1 and row 2 has no dominance. Now let us compare row 1 and row 3. So this is 6, which is greater than 1, 5 greater than 3, 7 greater than 2, 6 less than 7. So 6 is less than 7 and other values here are greater. That shows that row 1 and row 3 also has no dominance among them. Now let us compare row 1 and row 4. So here 2 is greater than 1, 0 is lesser than 3. So here we can see that this one is greater, this one is lesser. This shows that there is no dominance between row 1 and row 4. Similarly, let us compare row 2 and row 3. So this is 3, this is 6, this is greater. 5 is greater than 4, 7 is greater than 1, 6 is greater than 5, 5 is lesser than 6. So here all the values here are greater, but this particular value is lesser. This shows that there is no dominance between row 2 and row 3. Now let us compare row 2 and row 4. So 3 is greater than 2, 4 is greater than 0, 1 is lesser than 6. So these two are greater, this one is lesser. So we can say that there is no dominance between row 2 and row 4. Now let us compare row 3 and row 4. So 6 is greater than 2, 5 is greater than 0, 7 is greater than 6, 6 is greater than 3, and 5 is greater than 1. So among these we can see that each element in row 3 is greater than each element in row 4. This shows that row 4 is dominated by row 3. And we have also learned in the previous lectures that in column domination, in row domination, each value or each element in the dominated row must be less than or equal to the other existing row. So here this is the dominated row and each value of this row is less than the other existing row. This shows that row 4 is dominated by row 3. So now as a result of this we will eliminate row 4. So let us eliminate row 4. So this is our new revised matrix after eliminating row 4. Now here also we need to compare rows and columns for domination. Now as the first 3 rows are same and we have already compared it in the previous matrix and we have found that there is no dominance among these 3 rows. So we will directly move on to the column domination. So let us compare column 1 and column 2 first. So here 3 is greater than 1, 4 is greater than 3, but 5 is less than 6. So there is no dominance between column 1 and column 2. Let us compare column 1 and column 3. So here 2 is greater than 1, 1 is less than 3. So here also this is greater, this is lesser. That means there is no dominance between column 1 and column 3. Now let us compare column 1 and column 4. So 7 is greater than 1, 5 is greater than 3, and 6 is equal to 6. So among these we can see that each element in column 4 is either greater than or equal to each element in column 1. This means that column 4 is dominated by column 1, and in previous lectures we have seen in column domination the dominated column or the elements of the dominated column must be greater than or equal to the other existing column. So here we can see that column 4 has 7, 5 and 6. So this is the dominated column. So once we know that column 4 is dominated by column 1, let us write it here that column 4 is dominated by column 1. Now we need to eliminate column 4 here. So let us eliminate column 4, and this is our revised payoff matrix after eliminating column 4. Now let us again compare columns and rows for domination. So let us compare row 1 and row 2. 3 is greater than 1, 4 is greater than 3, 1 is less than 2. That means row 1 and row 2 has no dominance. Now let us compare row 1 and row 3. 6 is greater than 1, 5 is greater than 3, 7 is greater than 2, and 5 is greater than 4. So here we can see that each element in row 3 is greater than each element in row 1. This shows that row 3 dominates row 1, or we can say that row 1 is dominated by row 3. So let us write here row 1 is dominated by row 3. So as a result of this we will eliminate row 1 and these 2 rows will be remaining. So after eliminating row 1, this is our revised matrix again, and again here we will compare rows and columns to find the dominance. So let us compare here row 2 and row 3. So 6 is greater than 3, 5 is greater than 4, 7 is greater than 1, but 5 is less than 6. So there is no dominance between row 2 and row 3. Now let us compare columns. So first we'll compare column 1 and column 2. So 4 is greater than 3, but 5 is less than 6. So there is no dominance between column 1 and column 2. Now let us compare column 1 and column 3. So 3 is greater than 1, but 6 is less than 7. So there is no dominance between column 1 and column 3. Now let us compare column 1 and column 4. So 6 is greater than 3, but 5 is less than 6. So there is no dominance between column 1 and column 5. Now let us compare column 2 and column 3. So this is 4 greater than 1, this is 5 less than 7. So this one is greater, this one is lesser. That means there is no dominance between column 2 and column 3. Now let us compare column 2 and column 5. So this is 4 less than 6, and 5 are equal. So among these two we can see that each element in column 5 is either greater than or equal to each element in column 2. And according to column domination, the dominated column must have each element either greater than or equal to the other existing column. So here this is 6 greater than 4, this is 5 equal to 5, and this shows that column 5 is dominated by column 2. So column 5 is dominated by column 2. As a result of this, now we will eliminate column 5 here, and this is our new revised matrix after eliminating column 5. Now here also we will compare rows and columns for dominance. So let us compare row 2 and row 3 here. So 6 is greater than 3, 5 is greater than 4, and 7 is greater than 1. So here we can see that each element in row 3 is greater than each element in row 2. This means that row 3 dominates row 2, and we have learned in row domination that the dominated row must have each element either less than or equal to the other existing row. So here the dominated row is this, and it has each element less than the other element. So we can say that row 2 is dominated by row 3. So row 2 is dominated by row 3, and as a result of this, now we will eliminate row 2. Now after eliminating row 2, we have a single row remaining, and after this we can analyze that here player A can play only one strategy, strategy 3. This is the only strategy remaining for player A, and for player B there are 3 strategies remaining, and we know that player B and player A are both equally intelligent player. So B, that means player B will always try to minimize the loss. So in order to minimize the loss, player B will select the strategy which will give the minimum gain to A. So among these, 5 is the minimum value. That means 5 is the strategy which is having minimum loss to B and minimum gain to A. So here after this step, it is almost certain player A will play strategy 3 100% of time, and player B will play strategy 2 because 2 will give him the minimum loss. So it will play strategy 2 100% of time. So here we can say that player A will play strategy 300% of time, player B will play strategy 200% of time, and the value of game. So the value of game here is given as equal to 5, because 5 is the gain available for a 100% of time, and 5 is the minimum loss to be 100% of time. So the value of game is given by 5. So from this problem it has been clear that a pure strategy, or we can say a game with a saddle point, can also be solved using the dominance rule. So if you like this lecture, please share the lecture. Have a nice day. Thank you.